Have you ever looked up at the sky after a rainstorm and marveled at the beautiful rainbow that appears? Rainbows, with their vibrant spectrum of colors, are one of Mother Nature's most breathtaking spectacles. From the deepest red to the darkest violet, a rainbow's arc paints the sky with a brilliance that captures our collective imagination. This mesmerizing display is not simply a visual delight, but a manifestation of an intricate dance between sunlight and water droplets. Yes, these radiant arcs are a result of reflection, refraction, and dispersion of light in water droplets, a captivating optical and meteorological phenomenon. A single ray of sunlight bouncing and bending within a droplet of water emerges to paint the sky with an array of colors. So why do these beautiful arcs of color appear in our sky? Let's delve into the science behind this natural wonder. If you enjoyed this video, don't forget to like and subscribe for more fascinating insights into nature's wonders. The formation of a rainbow begins with something we see every day: sunlight. Sunlight, although appearing colorless, is a cocktail of different colors, each with its own unique wavelength. When this sunlight encounters raindrops in the sky, a fascinating process unfolds, leading to the creation of a rainbow. As sunlight enters a raindrop, it slows down and bends or refracts due to the change in medium from air to water. This bending separates the white light into its individual colors, each color bending at a different angle due to its unique wavelength. This phenomenon is known as dispersion. The colors of light, starting from the one that bends the least to the one that bends the most, are red, orange, yellow, green, blue, indigo, and violet, forming the familiar spectrum we associate with a rainbow. But dispersion is just the first step. After the light is dispersed inside the raindrop, it hits the inner surface of the raindrop and reflects back. This reflection enhances the separation of colors, making them more distinct. Finally, as the light exits the raindrop, it refracts once again. This second refraction further separates the colors and sends them off at different angles. And voila, you have a beautiful spectrum of colors arching across the sky, forming a rainbow. It's important to note that not every raindrop forms a complete rainbow. Each droplet only reflects one color back towards the observer, depending on the angle of the sunlight and the observer's position. But when you have millions of raindrops, each contributing a tiny fragment of the rainbow, the result is the magnificent arc of color we see stretching across the sky after a rain shower. So the next time you see a rainbow, remember, it's not just a beautiful arc of colors in the sky. It's a complex interplay of refraction, reflection, and dispersion of light within millions of tiny water droplets. All these processes work together to create the beautiful spectrum of colors we see in a rainbow. We've all heard the phrase Roy G. Biv to remember the colors of the rainbow, but what does it mean? Well, Roy G. Biv is an acronym that helps us recall the sequence of colors in a rainbow: red, orange, yellow, green, blue, indigo, and violet. But have you ever wondered why these colors always appear in this precise order? The answer lies in the science of light. Sunlight, though it appears white, is a mixture of many colors. When this light enters a raindrop, it separates into its individual colors through a process called refraction. Each color bends or refracts by a slightly different amount, which results in each color emerging from the raindrop at a slightly different angle. The light then reflects off the inside surface of the raindrop and refracts again as it exits the raindrop. The color that refracts the most is violet, followed by indigo, blue, green, yellow, orange, and finally red, which refracts the least. This is why red is seen at the top of the rainbow and violet at the bottom. The other colors appear in between, in the order of their refraction, thus forming the spectrum we know as a rainbow. But the story doesn't end there. The size of the raindrops also plays a significant role in how a rainbow appears. Larger raindrops create bright and well-defined rainbows, while smaller droplets result in fainter and broader rainbows. The most vivid rainbows are usually seen when there's a mixture of droplet sizes in the air, allowing for a broad spectrum of light to be refracted and reflected. So the next time you see a rainbow, you'll know why Roy G. Biv is more than just a catchy phrase. It's a reminder of the fascinating interplay between sunlight, raindrops, and our perception of color, creating one of nature's most stunning displays. Have you ever wondered why rainbows are always shaped like a semicircle? Now, the magic behind this spectacle lies in a concept known as the minimum deviation angle. When sunlight refracts or bends as it enters a rain droplet, It undergoes a process called total internal reflection inside the droplet, then refracts again as it exits. The majority of this refracted light occurs at an angle close to 42 degrees in relation to the direction of the incoming sunlight. This angle is determined by an imaginary line connecting the sun and the back of our heads. Intriguingly, this 42-degree angle only forms a circular arc. As this circle intersects with the Earth, the largest arc we can observe, while standing on the Earth, is a semicircle. This is most noticeable when the sun is near the horizon. So, a rainbow's shape isn't just a pretty arc in the sky, it's a direct result of how sunlight interacts with raindrops. Rainbows are more than just a beautiful sight, they're a fascinating display of physics and meteorology. As we've journeyed through the colors and curves of the rainbow, we've uncovered the science behind this mesmerizing phenomenon. It all starts with sunlight, refracting, reflecting, and dispersing in water droplets, splitting the light into the vibrant spectrum of colors we see arching across the sky. From the warm hues of red and orange to the cool blues and purple, each color has its place in this natural masterpiece. And let's not forget the semicircular shape, a result of refracted light being bent at an angle close to 42 degrees from the direction of sunlight. All these elements come together to create a spectacle that never ceases to captivate us. So the next time you see a rainbow, take a moment to appreciate the incredible natural processes that create this stunning display.